Hi, today I would like to share with you the impact of cache towards our application performance. So we knew that the main memory is actually pretty slow if we to transfer the data from main memory to the processor directly. Therefore, in order to mask the latency of main memory, cache will actually introduce in a lot of modern processors nowadays, we have L1, L2, and L3 cache. So before the CPU needs that particular memory, usually they will do some sort of prefetching. Now prefetching, one of the very classic method is to prefetch the subsequent data that you need to use. And this is usually particularly easily identified through array. So if you have an array, usually the subsequent element, the data of the subsequent element will actually fetch to the processor before they are actually being needed. Now, however, if we do not write our program to use the cache as is being fetched, then we'll have a lot of cache miss, and that will greatly impact our performance. Let me give you a quick overview on how this happens. So imagine we have a two-dimensional array, and this first row is our cache line, and we will be fetching this particular line to the processor for processing. Now, if you need the element on the subsequent row which is not fetched to the cache prefetch, then you have to go back to the memory and fetch it again. So if we were to write the traversal for a two-dimensional array, if you look at this row-based traversal, is particularly friendly if with this prefetch, because this particular cache line is actually fetched, and then the subsequent element that we need is always available. And once this is done, a new line is being fetched, and then all the data is bring to the processor prior to with very little miss. Now, if you look at column-based traversal, which we travel based on the column, now this is the problem here. When the data is actually being fetched, now let's say we are using the first element, and the subsequent element that we want is not the next in the array, but rather the next column. Okay, column-based, the next row. So which means this whole line that which is being cached will be actually is considered miss, and the data has to be fetched all over again, and that's why it will greatly impact your performance. Now, how serious is that? I wrote a very simple program to share with you to look at the impact. Now, we create a metric 10,000 by 10,000, and I initialize this metric with every column, every element with 1. So basically what we want to do is just a very simple do for loop and sum all these elements together. So one of these way, which over here if you look at it, I will go row based. We call it row based. We'll do the row one and then followed by the column, and the other one we'll all do the column based. We'll do column, the second one. This should be a bit efficient. Okay, and what we do subsequently is that I capture the time. I have both of them running. So let's check it out. They should give us the same total. Okay, since it's a 10,000 by 10,000 matrix. Yep. Let's check out the speed performance difference of these two. You can see row-based took only 0.3 seconds. You can and column-based took 1.3 seconds. So it's actually 1 second slower, and the amount is the same. The total, of course, is the same metrics, same operation. So to look at if the importance of cache, if we are not following it, going along with it, then we will actually have a great performance penalty. So I hope you enjoyed today's video. Thank you very much.